I am Special Agent for Microsoft Azure and DevOps for Team Rockstars IT. We are a cloud-native consultancy company based out of Amsterdam, the Netherlands. Today we're going to talk about worry-free microservices with Azure Container Apps and DAPR, because there's something very special about Azure Container Apps, and that is that they have built-in support for the DAPR runtime. So, has any of you worked with Azure Container Apps before? So a couple, and with DAPR? Also a couple. So why do you need Azure Container Apps? Well, basically because of this. Because we all know that deploying Kubernetes yourself is a hell to maintain, and you need about this many books to actually know how to do it. And therefore, Microsoft came up with a way to do this more easily, but with the ability to later on scale up to full-scale Kubernetes, and you get some nice other goodies as well, such as the built-in DAPR support. So, Azure Container Apps, they launched at .NET-Conf2021, which is last year in preview. It has been GA since build 2022, but it's not available in all regions yet. I will put on the screen shortly which regions. Sadly, no regions in India yet, but I'm sure that that will be covered soon. And basically what it's for is for deploying containerized apps without the hassle of managing Kubernetes, but with the possibility to go to full-scale Kubernetes that you can completely manage yourself at some point. And basically that brings us to this is going to be the complete offering for containers in Azure. So on the left side, we have really simple services like container instance, which you can just really deploy a single image with a single container and have something up and running real quick. We of course have a Docker support for app servers and web apps as well, which gives you a little bit more control about environment variables and stuff like that. It's still quite easy to set up and maintain. Well, on the other end, we have AKS. Full-blown Kubernetes environment, quite a steep learning curve. And as you can see, there is like a gap in the middle. And that gap needed to be filled. And that is where Azure Container Apps comes in. They basically fill the gap between the web app for containers and AKS, which is quite complex, with something in the middle that will give you basically all the features of full-scale Kubernetes without having to basically deploy it and maintain it yourself. You'll get some of the really good CNCF projects from the Cloud Native Computing Foundation, like built-in support for KDAS, so Kubernetes Event-Driven Autoscaling, built-in support for Envoy. You can migrate really easily to AKS if you want, if you need more control about ingress and egress, and if you want to run extra CNCF projects. And it has the DAPR runtime built in, which I think is really great, because that maintains, you do not need to maintain your DAPR instance and your DAPR containers yourself. So if you do not yet know about DAPR, no worries, because later in the presentation I will briefly explain what it is and why it's so great. So I said I would come back to the availability. So these are the regions where Azure Container Apps is currently available. So it is available in East Asia, but not in any of the Indian regions yet. So my demo will be out of West Europe, because I'm from Amsterdam. The West Europe data center is in Amsterdam. And I wanted to deploy it here locally, but I found out that it wasn't available here, and it's at least going to take 3 to 6 months before it will be available in any of the India regions, which is a shame, really. So, let's see. So, basically, if you want to deploy Azure Container Apps, you have two things. You need a Container Apps managed environment, and you need the apps yourself. So, if I'm going to deploy a Container Apps instance, so I want to put it in my live resource group, because this is going to be the real live demo, so fingers crossed that it will actually work. So AzConf AzConf Container App live. So as I said, I put it in West Europe. You can see here indeed all the regions where it's available. So no Indian regions yet. You'll see it will want to use a Azure Container App managed environment that I already have in my other research group, but for this purpose, I will create a new one. So live managed environment. And then you can also have the environment which actually provides the compute to you to have that enabled or disabled for zone redundancy. Right now, I want to be cheap, so I'll choose zone redundancy. You can also here set some of the network settings. So you can decide whether you want to use a quick start image or your own image. So if you use a quick start image, it will preload an image from the MCR, from the Microsoft Container Registry, to have a simple Hello World container, and we get a little bit of compute and memory. So right now I'm setting it to ingress from anywhere, so it's reachable from the internet, and then I can create it. So what it also does, you need a log analytics workspace. So it will create a log analytics workspace for you. And then let's get right here and deploy this. So this is probably going to take a while. So while this is deploying, and I need one more thing actually. So if you want to deploy your own images, you would also need a Azure Container Registry. So let's deploy that at the same time. So there you go. It doesn't find container registries. Yes. I want one. No, in my enabled, and then in the live research group. AzConf registry live. Yes, so this one I could actually put in, no, this one. I can actually put this in the India regions, but because my managed environment is going to be in West Europe as well, I'll put this one in West Europe. But all standard queue is fine. I'll put this for public access. And no customer managed key. So of course you would not do this in a production situation. You would either have it network injected with a pass firewall or have a private endpoint on it. But right now, let's just deploy this. So while this is deploying, let's get back to the presentation. And I will tell you a little bit about DAPR. So DAPR is an open source project that started in 2018-ish to basically solve this question, which is decoupling microservices from your cloud infrastructure is hard. So who agrees with this statement here? Yeah, so quite a few people. So that's why they invented DAPR, the Distributed Application Runtime. So it's founded in 2019 by 2 ex-Microsoft employees. The runtime itself is written in Go, so it's really fast, and it's really not consuming that much resources, which is really great if you do not have that much resources and you don't want an extra runtime on top of your .NET runtime that will have use this many resources. It basically is an in-between between a service mesh and an application runtime, but why it's not a service mesh, I will come on to that later. So actually, I found a really funny statement on the press release that Microsoft wrote back in 2019 when they announced they would endorse this project, and that is this. So Microsoft said, we predict that by 2022, 90% of new applications will feature microservices architectures. So this, of course, this was on the 16th of October 2019. We are in 2022 already. Who is still building new monoliths? Well, it's one out of the, I would say, 200. So yeah, I guess the 90%. Who is only building microservices at the moment? So I think personally that this prediction was a bit bold, because what I see in day-to-day life is that for a lot of simple things, a monolith application is still the way to go. If you're not going to have 10,000s of concurrent users, if you need an internal application for 500 or 1,000 people, if you need some business application to register some data and put it into a database, then you do not really need a microservice architecture all the time. And as we will see, usually when you go the microservices route, you will have a lot of complexity that you have to take care of. You have to do actors, you have to do state management, you have to do ingress and egress, you have to do intra-container traffic and all those things. And that is actually what DAPR is for, to do that for you. So, as I said, DAPR extracts away the cloud infrastructure from your application code and configuration. This actually means that your applications will only consume in a set of independent APIs that communicate either over HTTP or gRPC, and the DAPR runtime will connect to any of your infrastructure. So that infrastructure could be in Azure, it could be in AWS, it could be in GCP, it could be on-premise, it could be in all four in one single application, but your application doesn't know. And the good thing about that is that if you want to ever change one of those infrastructure components, you do not have to change any actual application code, because you will only have to change the DAPR component that actually connects to your infrastructure, and then from that point on, the DAPR runtime will communicate with your application. So it also codifies the best practices for building microservice applications, because they give you a preset amount of building blocks to do certain things like service-to-service invocation, state management, and other things like that in basically the best practice way. And that looks a bit like this. So the good thing is DAPR is code agnostic, which means that although it's endorsed by Microsoft, it's founded by Microsoft employees, it actually has a very good .NET SDK, but it also has SDKs for Node.js, for Python, for Java, for C++, for Go itself. So because it's over HTTP, you can really use it from any language that can do HTTP calls, even PHP if you would want to. And on the other hand, DAPR is also cloud agnostic. So as I said, you can run your components on-premise, you can run them in Azure, of course, which I would recommend, but you can also put some stuff in AWS or in GCP if you wanted to. So, and right now they're even getting components ready for emerging clouds like Alibaba and other parties. So that's really good. And basically what they do really well is those 7 things that you'll see in the middle. So they do service-to-service invocation for you. They have a state management module. They have a publish and subscription module. A resource bindings they do. They have an actor model. They have observability, so you can inject observability modules that will do logging and monitoring for you. They have their own secret store, so you can easily use their own secret store or use a key vault, for instance. And there is a big community behind DAPR to deliver custom building blocks, so you can build your own DAPR integrations as well. So DAPR works with the sidecar architecture. This basically means that whenever you spin up a container in your application which requires a DAPR client, it will attach a DAPR sidecar, which is the actual runtime, and then the sidecar and your application container will communicate over MTLS, so TLS-MA, mutual authentication. So even though the API is HTTP and goes over HTTP endpoints and not HTTPS, your traffic will be encrypted at both sides, so it's completely safe. And each service or each container that you will have its own DAPR sidecar container, which will do everything you invocate the DAPR API for. So if you do a call from your application to DAPR get me this state or DAPR get me this secret, the DAPR sidecar for that application will go and load the state from the state store you configured in the component. It will put a message on the queue for the messaging component you configured, or it will get the secret from the secret component that you configured. And whenever your application container dies or exits the cluster, your sidecar automatically dies with it. So these are all of the components that you have available right now. So as I said, you have service-to-service invocation, configuration components for Azure app configuration, input and output bindings. You can do actors, you can do publish and subscription models. You can really do a lot. So, and I think that's also the good thing about DAPR is that it's very versatile and you can adapt it to your needs. If you do not need actors in your application or in your microservice, you simply do not specify a component for it. It will not be loaded into your application, so you will not have the overhead of having it. If you are not using any bindings, same thing. Some things like the secrets and the observability, I would recommend to always use them because it just makes your life for debugging and stuff like that so much easier. But that keeps the DAPR runtime itself also really lightweight, which is really good. So, as I said at the beginning, I think a good 20 minutes ago, is that DAPR isn't a service mesh. And basically this is why. So while DAPR has some characteristics of the service mesh, so the things they share are in blue in the middle. So they both communicate over MTLS, they have metrics, they provide resiliency, they provide distributed tracing, but what a service mesh in principle does is traffic routing and traffic splitting at network level. And that is something that DAPR does not do. DAPR has no low-level control over your network. It does not do traffic splitting to different pods or different containers. It will not reroute your traffic to a new container if one container dies. So it doesn't do that. So if you need that, you're still going to need a service mesh. But the good thing is, you can use DAPR together with most of the popular service mesh frameworks. So it works with Istio, with Linkerd, with Open Service Mesh. What is actually quite interesting is that Microsoft proposed to have DAPR replace Azure Service Fabric as a service which has been deprecated for some time. But actually, DAPR doesn't completely cover all of the use cases of Service Fabric because Service Fabric was an actual service mesh. They did do network traffic routing and traffic splitting, so DAPR does not do that. But the good thing is that with Azure Container Apps, you can actually do that because it has the Kubernetes ingress controller, so you can actually distribute traffic and do auto-scaling based on traffic as well. So whenever you would use DAPR together with a service mesh, you would get 2 sidecars for each container. So you get 1 sidecar for the DAPR API and 1 sidecar for your service mesh. The only thing you need to make sure is that they don't run on the same port. So by default, DAPR, the communication between the DAPR sidecar and your application runs over HTTP port 3500, which is the default DAPR port. You just need to make sure that your other sidecars, like Istio or like an open service mesh, that they do not use the same port, because then you will get conflicts. But otherwise, you should be fine. So to summarize why DAPR is not a service mesh. So service mesh has traffic splitting for load balancing, A/B testing or blue-green deployments. DAPR doesn't have that. If you have enterprise-grade networking requirements for networking policies or for tagging certain traffic at packet level and routing it that way, you definitely need a service mesh. If you just need an infrastructure-independent runtime that will make your application more agile towards the infrastructure it's running on, then DAPR is a great choice. And to illustrate that, This is already quite an old picture, but this is all these services that DAPR has components for. So as you can see, they have multiple services for state management. So you can use Firestore DB on GCP, Dynamo, Cosmos DB, SQL Server on Azure. So for publishing subscription, you can use Azure Event Hub or Azure Service Bus or SQS on AWS. You can also use self-hosted RabbitMQ, Redis, Kafka, MQTT. So basically, any technology you would use in a modern day microservices application is available as a component out of the box. And if it's not, you can develop your own component for a service that you would want to use. So I think it's time to go back to the demo to see if those container apps already deployed. So at least the container registry is deployed. And my container app is also deployed. That's really good. So for once, a live demo goes actually the way a live demo should go. So let's see. So as you can see, we have the container apps environment. We have the log analytics workspace that was automatically created. Oh, I see I still have the PowerPoint on, so I need to close that. Yes. Okay, so as you can see, this is the research group we just deployed in before I started talking about DAPR. So you can see we have an Azure Container Registry, we have a managed environment, we have a log analytics workspace, and we have an Azure Container App. The Azure Container App has preloaded the Hello World container. And it provisions the first instance of my Hello World container. So if I would use this URL, so the only thing I find a little bit not useful is that they got really long URLs. So as you can see, it's like really long. So you get your container app name, then you get some other name, then you get normal numbers, and then you get the region where you deployed it. And there we have it. So this is the default Hello World container to make sure that your container app is alive and online. So there's mine. And this is basically everything you need to have a working container app. So that is really good. So here's some things that you can configure here is the auto scaling. So by default, this container app will scale between 0 and 10 pods. So because under the hood it's Kubernetes, they call it containers here, but in fact it's just pods. So it will scale between 0 and 10 pods based on traffic. You can also add scale rules here based on HTTP requests or on CPU or memory usage of the container. And you have some capabilities for DAPR. But before I'm going to show the DAPR capabilities on Azure, we have some time, we're going to do it locally first. So you can run DAPR locally. So you basically install it, and then you run the DAPR command, and it will show you that you run the DAPR runtime. So it will actually, here, we'll have the DAPR distributed application runtime. The first time you have, after you have installed it via your package manager, oh, where's my mouse? Here it is. So you would have to run DAPR init, and then it would basically pull the container images for DAPR itself from Docker Hub. Now you see it already exists. So basically, when you run DAPR locally, you need to run Docker. So because I'm on a Windows machine, I'll have Docker for Windows. And as you can see here, I'm having 3 containers. So we have the DAPR placement container, which is the actual DAPR runtime. I have DAPR Redis, which is the built-in container for state management. So the local state management is a Redis cache. And I have a Zipkin container that has the OpenZipkin module installed. So basically, this means that we can do the following. I can create a DAPR app. So in this case, I'm going to create the app Rockstars with app ID Rockstars. I'm going to place it on the DAPR port 3500, which I said is the default HTTP port. So if I'm going to run this, it will run the default HTTP port. So now I actually have an application without any application code on my local host 3500. So what I could do is utilize the state store. So I'll open up a PowerShell command and I'm going to save some state. So I'm going to do a post call to the HTTP endpoint of DAPR. So that is v1/state/state store. This could basically be anything behind here, but because I haven't loaded any DAPR components, I will get by default the default state store, which is the built-in Redis cache, which is running locally on my Docker. So if I am now going to retrieve this state on a browser, you will see that it actually printed that. And we can also actually go into the container, so the Redis container with Redis CLI. So this is the Docker container with Redis CLI, and then I can just get it. And then you will see here that I have one entry here in my local Redis cache. So right now we're just running this locally, of course. So let's exit this. But the most important thing that you're all here for is basically how container apps and DAPR work together. So like I said, to have anything basically configured on DAPR, you need components. So I'm having a component folder here on the left that contains certain components. So I have AZ components and I have local components. So this is the local secret store that I created, which just writes secrets to a file called secrets.json. I have an Azure state store. Get this. So I have an Azure state store, which is actually a table storage. I have an Azure secret store, which is an Azure Key Vault, so of type secret stores Azure Key Vault. And I have two separate ones for container apps. So this is the normal syntax for components. So it's all YAML. So it's basically YAML with an API version, a kind, which in this case will always be component because it's a DAPR component, with some metadata and the spec. The spec actually tells you what kind of component it is. So for Azure Container Apps, they simplified it a bit. So you do not have to provide the API version, the kind, and the metadata. So you just define the component and the version. In this case, the metadata is the spec. So it's a bit confusing. So if you want to use DAPR components on both local and Azure Container Apps, you need two versions of your component because the syntax doesn't quite match, but the idea is the same. So where do the components go? So basically they go in your managed environment because what happens, the components are loaded into your managed environment like environment variables. So you see you have on your managed environment, you'll have a DAPR components setting. And if you click that, you'll get a list with all kinds of components. Right now we have none. So you can add one via the Azure portal. You can add one via infrastructure as code, but we are going to add one via the Azure CLI because I already created the commands for it. So with this command, I'm going to set a component. So it's Azure Container App env, because it's an environment variable. It's a DAPR component, and I do a set because I want to set a component. You could also get a component or delete a component like this. And we're going to set the state store. So I'm calling it state store. I actually think I need to call it Azure State Store because I have a demo application as well that uses Azure State Store, yes. So I need to change this to Azure State Store, and it will still pick up Azure State Store.yaml. So it's really important that you get this name right, because this name will get you the name of the component. So I'm now going to paste all this here. Oh. And why did it not work? Am I in PowerShell? Yes. Azure State Store DAPR component name. Expected one argument for name. Oh yeah, of course, because I should have put in the things here. So my resource group is going to be AzConf2022 live. And my container apps environment is going to be live managed environment. And of course, I need to do a AZ login first because it probably will not know my subscription. So I'm going to do an AZ login first. Yes. So I have logged in. So this usually takes a while. Did it get my correct tenants? Let's see if it will find it with this tenant. So yeah, so it actually created this for me now. So if we go back to the Azure portal here, then I refresh this and we will have a Azure State Store. I'll now do the same thing, but then for the secret store. So I will have this secret store. So, secret store, secret store, yes. So we do that once again. And then we'll wait, and then we'll see here that it created the DAPR component. Secret store, so we now have both here. I can click them. I can actually edit them here as well right away when it loads. So now basically everything in the environment is ready for a DAPR app. But before we can do it, we actually need an app. So let me open my Visual Studio here. So I create a really short web APIs project. Not with the minimal APIs because I really hate how the minimal APIs look because you can't find anything. So I just did a regular one with a controller. So the only thing you need to actually have DAPR work in your .NET 6 application, because this is still .NET 6, it will be .NET 7 in a couple weeks, is you need to add this, builderservices.add-DAPR client. And for that, you need a single NuGet package, which is called DAPR ASP.NET Core and DAPR Client. And if you have these three, DAPR ASP.NET Core, DAPR Client, and DAPR Extensions configuration, you'll only need to add this line to your builder, add DAPR Client, At that point, you can inject a DAPR client into your controller, and then we can do a DAPR client get secret async. Then we put in here the name of our component. So the component I just uploaded to the managed environment, I put here from this component, via this component, I want to retrieve my secret, not so secret. That component is an Azure Key Vault, so it will retrieve something from an Azure Key Vault. I also have a state store. So this will actually set a key in my Azure State Store, and this will get a key from the same Azure State Store. So because I'm running out of time, I've already prepared this as an image on my ACR, so I'll switch back to my other resource group. And I'll show you that on my container registry, I already have this. Oh, now I'm not authorized in my own registry, but it's definitely there. And I already deployed it here to my DAPR app. If you go to containers, you will see here, it's the DAPR demo app from Azure Container Registry version 7, and that I have a running revision. So if I go now to my link, and I didn't put a Swagger, so this is basically the app. So we can get a secret. So if I say try it out, we execute it, and then it will actually have retrieved a secret. So it says, hi AzConf, DAPR is awesome from Azure as well. So this actually comes from my Azure Key Vault, which I can actually show you that I'm not tricking you guys. I can show you that in my Key Vault I have a secret that is called not so secret, which I wanted to retrieve, for which I should have rights to actually show you what it is, which I do. As you can see here, it's the same thing. So it actually fetched the secret from my Azure Key Vault, which is really good. So the same thing we can do with the state store. So the state store is a Azure table storage. In Azure, that's the cheapest way to get a state store, because in the storage account, table storage is much cheaper than a Cosmos DB or any of the other options. So we are definitely going to set some states. So let's try it. So key, we have some demo states. And then execute. You can see it gives back a 200 HTTP OK. And now with the same get endpoint, I can actually get that state. And then it will actually say it retrieved demo state for key 2 from Azure State Store. So since I have like 5 minutes left, I want to try something with you guys. So everybody needs to get out their phones, and then we're going to do something. So I'm going to put a URL on the screen. So this URL. So this will actually point to the container apps. I have just made it a bit shorter because it was really long and I really complained about Microsoft as well. Why can't I do a dynamic DNS name on this? But if you go to this, and I'll show you some metrics, because then we can see the magic of the CADA, of the auto-scaling. So if everybody's got this URL, so I give it like 10 more seconds. Yeah. So then I'll actually show you this URL goes to the container app I already deployed before. So that is this one. Then I can show on the monitoring, we actually have, get some metrics. We'll actually get the, not the CPU, but I want the replica count. So this is going to take like last 30 minutes. I want 1 minute. So right now we have 1 replica, but this is being auto-scaled between 1 and 10 replicas. So it should be that as more people are hitting that endpoint, it should actually scale up. So this is a minute late. So it should actually be, I'm going to hit that URL as well a couple of times, just to actually do some traffic. And if you guys do the same thing, we should be getting another replica quite soon. Let's refresh this. No, it's still on 1. So you can see it spiked a bit here in CPU, but probably not enough for it to scale, because as you can see here on the scaling, it is set to scale to between 1 and 10. And I have put in a scaling rule to scale on 10 concurrent requests. So we should be able to get some so let's put this on 1. Yes. You can see here, when everybody tried it, so that was like a couple minutes, 3 minutes ago, it went up from 1 to 9 replicas, as you can see here. So I said scale on 10 automatic requests at the same time. Once I get over the 10 HTTP requests at the same time, it will scale up. And it will automatically scale up to 9 because it saw that we had 90 concurrent requests at the same time, which is about right with this room. And it will automatically scale up now to the maximum of 10. And now I'll leave it for a little bit. I'll finish the presentation, and then we'll see it has dropped down again after the load has come back. So, if you want to get started with DAPR yourself, so DAPR just released version 1.9.0 last Friday. So Friday last week, I had to update these demos this week because there was a new version out. You can go to docs.dapr.io or follow DAPR Dev on Twitter. DAPR also does community meetings, which are at 9 a.m. Pacific time, which is really good actually because that's 9:30 Indian Standard Time. So if you want to watch any of the DAPR community meetings to basically sprint reviews of what they have been doing, you can do so. You can have a Zoom call with them. The stuff is here. And I will also put these slides on my Twitter afterwards so you can get it from here. Or you can watch the recordings on YouTube. And I want to thank you very much for this session.